camera worked flawlessly, and now it goes out of focus just like the other one did. But anyway, so it's your time. You can ask anything you want. Yes.
Okay, in 6.1,
Okay.
we talked about finding the mean and standard deviation. We would never find those with a computer method, right? Because it's
Oh, so 6.1. Okay,
Yeah.
so the question. So the 6.1, if I remember,
was
talks about discrete random
variables.
variables. Discrete random variables. Okay, and so you said you should never use the Excel function on a discrete random variable. That is correct. I mean, you can use it, and Excel will give you an answer, and it will be wrong.
I just wanted to clarify.
Yeah, so you need to use the formula on that. Okay? That is correct. What other questions do you have? Yes.
So on our 6.2 quiz, we had the question about 50 multiple choice questions with 4 answers each and 1 is right.
Okay.
How do you find the sample space on that?
Okay, so remind me, it says that you had 50
Multiple choice questions.
multiple choice questions,
Each with 5 possible answers.
and they have, is it 5 or 4? I thought you said 4. Is it 5 or 4?
Oh, it's 5, yeah.
Okay, so you've got 5 possible answers, and it's asking you for
The mean and standard deviation of the
Find
number of correct answers.
the mean and the standard deviation. Okay? All right. So now this kind of relates to the question we just asked right before we started recording, so I'm going to ask it again. Is this data continuous or discrete? Discrete. Okay, so now let me just emphasize here. For the rest of the semester, that is a super important question. It should be a question that you ask yourself pretty much on every question. Am I dealing with discrete or continuous data? We say we're using discrete data. Okay, that's going to help me narrow down the formulas that I'm going to use. Okay, so it's discrete. Now the question is, 6.1 dealt with discrete random variables. I believe 6.2 dealt with binomial. Okay. Now, we didn't get a table per se, we just got this information here. Do you think it fits a discrete random variable or a binomial better? I mean, they're both discrete. Binomial because, say it again. You've only got 2 outcomes. The outcomes are right or wrong. They're independent. We're assuming they're independent. They all have the same probability. And what is the same probability? Because we've got 5 possible answers. Yeah, your P is going to be 0.2, right? Your Q is going to be 0.8. And the last fixed number of trials. Fixed number in our case is 50 trials. Okay, so it's definitely a binomial distribution. Okay, so now that I know it's binomial, that's going to help me focus in what's the formula for the mean and what's the formula for the standard deviation. Why is P 0.2?
1 out of 5.
Because it's a multiple choice test. You got 5 possible answers. That means you got 1 right and 4 wrong. So that gives you 1 out of 5, which is 20%. Okay? Okay, so do we know the formula for the mean and the standard deviation for a binomial distribution? Okay, what's the mean?
N times P.
N times P, which is super easy. And the standard deviation?
N times P times Q and the
Square root of NPQ. Very good. Okay, so in this case, the mean, Spencer, is going to be mean equals 50 times 0.2, or 1/5. It will be easier because that goes in there 10 times and I don't need a calculator. Okay, and your standard deviation equals square root of 50 times 1/5 times 4/5. That cancels there. I'm going to get the square root of 4 is 2 over the square root of 50, which is whatever that is. Oh, now I can use my calculator. Okay. What does that work out?
Deviation is n times p times q.
Square root.
Taking the square root.
Correct. What does that work out to be? What? 2.83. So as we think about this, what you're saying is, if I had a 50 question test, 5 possible answers, just by guessing, I should get 10 right, and the standard deviation should be about 2.83. Okay. Does that seem like reasonable answers? If you got a standard deviation of 50, would that seem like a reasonable answer? Probably not. That'd be way too big, right? Okay. All right. So good question. Now, yes. So I do want to emphasize this whole idea: discrete or continuous, what kind of distribution? That's going to become extremely helpful for the rest of the semester. So get in the habit of asking yourself that on every single problem. Okay. On the test, we mix them all up, and then it's like, ooh. And in fact, next week, you just wait. We're going to use a continuous distribution. We're going to use a continuous distribution on a discrete distribution. It's going to be fun.
Can you write a formula for
Standard deviation right here for the binomial square root of NPQ.
That's on the,
Was it square root of NPQ? Or on the, I think they put square root of NP times 1 minus P. Because I like Q better. That's how I learned it.
So I have under 6.1 some like.
Okay, now actually that's a good question. So she's looking at 6.1 because she said this is a discrete random variable. Let's talk about that formula. Let me ask you a question before I write that formula down. Could I use the formula she's referring to find the standard deviation and the mean?
Yes.
Yes, I could, because binomial is a discrete. But this is going to be way easier. These two formulas here are going to be way easier for a binomial. But yes, you can use the discrete formula and you should get the same answer.
That's the standard deviation squared equals.
Yeah, so I'll write that on the board here. So the formula is, this is the standard deviation for a discrete random variable, RV for random variable. Sigma sub x equals the square root of the sum of x minus mu squared times p of x. That's it. Or you could also use this formula here, the square root of sum of x squared p of x minus mu squared. Okay? So, and in fact, would you like to try that on this problem here? Okay, and hopefully we'll get 2.83. Okay, so let's share. Okay, all right, so we've got 50 multi-choice questions, 5 possible answers. We said it was discrete. We said the mean was NP and the standard deviation was NPQ, square root of NPQ. So this works out to be equals 50 times 0.2 which is 10, and the square root of 50 times 0.2 times 0.8, 2.83, okay? So now the question is, which of these two formulas, I'll let Caitlin pick since she asked the question, which one would you like to use? Either one should work.
I think the second one is easier.
You think the second one's easier? Okay. I don't, but if you do, that's fine. Okay. So now in this case, we have to figure out our x. What is our x?
5.
Oh, I heard 1 through 50 and I heard 5. Neither of those are correct. Well, let me think about this. Oh, no, you're right. 1 through 50. Did you say 1 through 50? You forgot 0 through 50. You could get 0 right, you could get 1 right, you could get 2 right, all the way down to 50. Oh, I gotta drag it myself. Ooh, went way too far.
This is one of those times where you don't put the apostrophe first in case we're going to graph it.
Well, you didn't ask to graph it, but we can, and that would be a good idea. Okay, so should we do that? Put the apostrophe in here. We'll do it for the first two. Hopefully that will work. The rest of them the way down, and I'll center them. Okay. All right. Now what? This is definitely the harder way to do this problem. But it will work. It is correct. Nothing wrong with it.
Can you do it both ways?
I just did the easy way. The easy way is right here. Mean the standard deviation. Now, so in order to find the standard deviation, I have to find the mean. How do I find the mean with this method? Now I got to pull up my formulas again because I don't remember. Yes.
It would be the sum of x times the probability of
Equals the sum of x times p of x, right? That's the expected value formula. Okay. So I need to find the probability of x. Okay. How do I find that?
Well, you do the truth value thing, so this would be like,
I do the what?
well, the way, yeah, that way wouldn't be a good way to do it. Because that way, when you have more than like 4, it's a pain in the ass. Where you do like false, 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 false thing.
Oh, we got a computer. It's not that big a deal. So you're saying, I think you're saying use the binomial distribution formula?
Yeah.
Yeah, that's the easier way. We can do it the harder. There's even a harder way to do it, I guess.
would it be when you times the probability of each of these away?
But you have to get the probability.
Yeah, but what you said was right, but Caitlin's further along the road than what you said. Yes.
Isn't it the n combination x e to the x e to the n minus 1?
That's the even hardest way to do it, but yes, that is correct. Okay, so we'll do it all 3 ways. Okay, so we did it the easy way first. We started with the easy way. We're getting progressively harder. Okay, so the easy hard way to do it is binomial dist, right? And it doesn't matter whether I pick the periods or the not periods. I did the not periods in my other class, so I'll use the periods in your class. I will probably post this video, and you guys can watch each other's review if you want. Okay, some of the questions are similar, some are a little different. We didn't do this question in my other class. Okay, so number of successes is going to be, so I could type 0, but I'm going to click on the 0. Yes. Comma, number of trials,
That's your n,
which is 50. Probability of success, 0.2, and true or false. True vote. Oh, we got a difference of opinion. Who says true? One person did. Chicken it out. Who says false? 1, 2, 3, 4, 5, 6, 7, 8. Who didn't raise your hand? You got it wrong. It's false. Which brings up the inevitable question, how do you know? How do you know? Is it true or is it false?
False is if it's
What'd you say?
false is if it's one, but it's
Yeah, so if I have the probability that x equals whatever the number is, exactly that number, I put
False.
false. To put true, what's my probability? X is what?
Less than or equal to.
Less than or equal to whatever the number is. Okay? And in this case, we want x equals exactly, so we're going to say false. Okay? All right, now we'll copy that down. Okay? All right, so the question was, we need to find the mean. Okay, so how do I find the mean?
Times product of probability of extension.
So I need the product here. Okay. Which is this times that. I'm going to copy that down. And then I need, so I'm using this formula right here. Okay. And so what do I do last? Find the sum. The sum of this column here. Sum was 10. Look at that. It matches. Which method is better? The easy one, right? Now we can do this the even harder way. I would never ask you to do this on a written test, but we could, just for practice. How would we do it? How would we do it back before we had Excel? But we're still going to use Excel. No, we already did the false, false, false. We're going to do it even harder than that.
Is it the combination
The
one?
combination one. What's that formula?
N combination X.
So the probability of X equals the combination of N choose X,
Probability to the X.
probability to the X,
Q to the N. minus
Q to the
X.
N minus X. Okay? Back before Excel, this is how you had to do this, and this would have sucked
So we're not.
with a capital S.
So I know if it's major.
What's that?
So I know if it's major.
We had, let's see, what was his name? Blaise Pascal figured all this stuff out. And he didn't even have a calculator. Can you imagine? All right, so we need our combinations. Okay, we need our P to the X, and we need our Q to the N minus X. Okay? All right, now what?
So we just do the common formula.
Equals combin. And the number is 50, the number chosen. 0. So I'm going to click on that because I don't want to write it every time. The probability of success, 0.2 raised to the, click on the 0. And the probability of failure, 0.8 raised to the 50 minus whatever that number is. Okay? And then I'm going to need the product of all of these. So I'm going to take this times this times this. Okay? And I'm going to copy that down 50 times. Okay, does this column here, does that match this column here? Looks like it does. Okay? You're as smart as a computer now. Okay? Slower, but you're smart. Now, oh, we haven't done the standard deviation yet. Anyway, I'm going to take the whole class is doing this one problem. Now what? We need to find the standard deviation. That was Caitlin's original question. Okay, we've done it 3 times. This is definitely the easiest way to do this, but you said you wanted to use this formula here. correct?
Apparently.
That's what you said.
Yeah.
So we need to figure out what's my x squared, right?
If this wasn't binomial, we could do disagree with it, right?
If it wasn't the binomial,
Yeah.
yeah.
You would have to be doing all these steps. Right?
You would, yeah. If this was a discrete, if this was a discrete that was not binomial, you'd have to do it this way. Yes, that's correct.
And hold everyone on the computer. Probably.
Probably, I think so. Okay. So we're using this formula here. So I need an x squared. I need a probability. Oh, I've already got the probability of x, right? I need the mu squared. I've got my mu. So actually, it's the only new thing I need. Well, I'm going to need a few things because I got to multiply these together. Well, what's my x squared in this case? It's going to be. You guys always like to say this else. 0 squared, right? Which happens to be cell A9 in this problem. Okay, so I'm going to copy that down 50 times. Okay, all to get this answer of 2.82. Okay, now what am I doing here? So now I need to times the probability of x. Okay, so I'm going to take this number and I'm going to multiply it by the probability of x, which is there or the other yellow column. Okay, let me copy that down. Okay, now what is my next step here? Add up the products. Okay, so I need to sum again. I'm going to do it this way. The sum of this column here. Okay. Then what? Now I'm going to take whatever that is, and I'm going to subtract my mean raised to the second power. That gives me 8. This is actually what we call the variance. And standard deviation is the square root of that 2.82. See, Spencer thought he asked an easy question. It was easy. If you knew the right formula. But you can do the long formula, you still get the same answer. Okay? Can I ask one more question since we've got 2 minutes left? And my other class asked it, and I think you'll probably want to know the answer to this question. How do you make a histogram? Okay.
So with your X, your data, you need to make sure you do an apostrophe.
Do the apostrophe, which we did. We were smart enough to do that at the beginning.
And you select the data.
Select the data, these first 2 columns here, right?
Yep.
What if I wanted to do this column and this column? You could hold the control key down and do that, but we'll do it the easy way, especially since we're out of time. Okay.
You insert.
Insert.
You hit the bar.
The bar chart here. 2D.
And then on quick layout.
Quick layout.
You choose the one where they touch.
Choose one where to touch. What would this be down here? What should you put on this? Number of correct answers. And this would be probability, whatever. And this would be what do you guys think? Probably 50 question multiple choice test with 5 possible answers. Okay? You want that spreadsheet?
Yeah.
Okay. All right, who's taking the test today? 1, 2, 3, 4. Okay, 5. So yeah, you can actually, I think they open at 10, so you're good. You can go there now. You're going to upload it, but I'll do that before you get there in 10 minutes, hopefully. If they don't, I believe they should have this formula sheet. If they don't, tell them to call me. You should have that. If they don't have a scratch piece of paper, tell them to call me. I'm pretty sure I put that on there. So it must be taken by Friday. The written test is tomorrow in class. So see you all tomorrow. What'd you say? It's through Canvas, yes.
Yeah, see you tomorrow.